All right. Thank you so much for joining us for another HRAI webinar. Today, the topic is dual fuel HVAC solutions for residential and commercial buildings. We're going to be digging into dual fuel systems and gas-fired heat pumps, how they work, their benefits and role in the market. And we're going to be doing so with the aid of FortisBC, providing us the BC perspective, which is applicable. A lot of insights that can be shared with throughout Canada as well. So with that in mind, I want to invite Juan Mani. He is a Technical Solutions Manager at FortisBC. He's going to be presenting today. Hear him in the background.
Thank you, Matthew.
Thank you so much. Hello, and before we get started, I just want to say we are doing a Q&A session at the end. We got a very kind of information-rich presentation to go through first, but if you have questions, we have a Q&A button at the bottom of your screen and a chat as well. Put them there. I'll be watching, and we'll get to as many as we can before the hour runs out. This is also going to be on YouTube, HRAI's YouTube. So if you'd like to watch it after, share it with your friends, or just rewatch again, please do so. So I'm going to stop talking and let Juan do his thing. Thank you so much.
Thank you very much, Matthew. Okay, can you see my screen?
Good to go on my end.
All right, thank you very much. So hello, everybody. My name is Juan Mani. I'm a Technical Solutions Manager with FortisBC. In my role, we help our customers to obtain energy savings, energy conservation measures for our customers. And today, I'm going to be presenting to you about gas heat pumps and dual fuel heating systems. The agenda for today, first, I'm going to have a brief introduction of what is FortisBC, what we do, and then we're going to dig into dual fuel systems and gas heat pumps. And at the end, I'll present a couple of case studies of the two of the pilots that we did in the past. First of all, what is Fortis? Fortis is a utility company. We have 12 subsidiaries across North America and the Caribbean. We serve around 3.5 million customers, about 9,800 employees, and we have a wide range of electrical and gas service to our customers. We're mainly an electrical company, but in the case of FortisBC, we also have a very important gas component. Now, what is FortisBC? FortisBC is the largest energy provider in the province. We provide natural gas for most of our province. And we have also a small but mighty electrical area in the interior of BC here, shown here in yellow. This is a dual fuel service area that we have, where we supply both the electricity and the natural gas. And for the rest of the province, we supply natural gas. And we also have a small area where we serve propane for Revelstoke. We not only provide energy, but also help our customers with energy efficiency. And we do that through a series of programs, including educational and training. And we also provide rebates to improve the energy efficiency in buildings. That includes incentives for building envelope, but also through high-performance mechanical systems, as we're going to see. Due to a change in regulation that happened a couple of years ago, we had to pivot from providing incentives for high-efficiency boilers and furnace traditional equipment to more efficient technologies that can be up to 100 or more than 100% efficient. That triggered a number of pilot projects that we've been working on for the last few years. Last time I counted, we have more than 20 pilot projects going on that can be grouped in dual fuel technologies, gas heat pumps, deep energy retrofits, and electrical heat capacity mitigation. Today, we're going to touch on the first two ones, the dual fuel heating systems and the gas heat pump technologies. Now, we'll start with the definition. What is a dual fuel heating system? Also known as hybrid heating. There was a lot of confusion in the terminology, so we had to come up with our own definition to make sure it meets our incentive criteria. First of all, it needs to have an electrical component, and this electrical component has to be a heat pump, because electric resistance wouldn't help us to get the high efficiency that we are looking for. Then we have our gas fire component. That could be a furnace or a boiler or a hot water heater, you name it, anything that uses gas fire. And very importantly, the controls. The controls could be integrated for a package system, or could be custom controllers, a custom controller or DDC, you name it, to make sure that the system works in a safe and efficient manner. Now, I'm going to be switching between commercial and residential because I wanted to follow a chronological order of the projects that we've been working on. So this is where we started. Commercial dual fuel rooftop units. We launched this rebate a couple of years ago, and this technology is not new. It's been around for a while, but we haven't been able to provide an incentive until a couple of years ago. So what does that mean? So if you think of your typical rooftop unit with a DX cooling and a gas fire section and mixing section and everything, it will be the same. The only difference is that a dual fuel heat pump rooftop unit will be equipped with a heat pump that can provide heating and cooling to the building. And the backup heating will be provided by a gas fire section. Now, how does that work? Well, as you can see here graphically in this thermometer, the electric heat pump will be providing your heat during mild outdoor condition, and then the gas will take over at the cold temperature, at freezing or near freezing. This changeover temperature from electric heat pump to the gas is adjustable in most systems, but we established in our rebate program that the switchover temperature had to be not higher than 3 degrees C for climate zone 4. And climate zone 4 is Vancouver, Lower Mainland, Southern Vancouver Island, and the rest of the climate zones are for the interior and the north. And for those climate zones, it has to be no higher than -3 degrees C. Now, what does that mean in terms of the operation of a heat pump? And I'm going to use Vancouver as an example. This is a temperature profile for 2024 in the Lower Mainland. And this is a typical weather profile, although I don't know if we can call them typical profiles anymore. As you can see here in this graph, these bars are number of hours at different temperatures. The majority are the hours your heat pump, if we're switching over at this temperature, the majority of your heating hours will happen with your heat pump, which is more efficient, and you're going to save on energy. But then at the low temperature, your gas will take over. That means that you will not need to size your heat pump for the lowest day of the year. And this is going to help you with your electrical capacity, as we're going to see here in these examples. This is a comparison of a dual fuel. The column on your left here is the traditional rooftop unit with DX cooling and gas heat. In the center, you have a heat pump with electric backup, a fully electrical unit. And then at your right, you have your dual fuel with gas backup. Couple of things to look into this is, number one, this unit is going to be a bit higher on weight, although not too much, around 15%. And the unit will be more expensive. Excuse me. Because this has the addition of the gas heat pump. But I want you to take a look at the electrical capacity. The electrical capacity of the traditional rooftop unit is very similar to the dual fuel. In comparison with the fully electrical rooftop unit, that it will require 2 to 3 times more electrical capacity. This makes it as a very good option for a one-to-one replacement. You will have to consider the additional weight, and obviously the additional cost is a factor to consider, but that's where we came in. In our dual fuel rooftop unit offer, we have different tiers for an incentive. We offer 30% of the total cost to a maximum of $150,000 for condensing technologies on the gas section. On the standard efficiency, we have 30% of the total cost up to $100,000. And there is also top-ups for affordable housing. This has been a great success so far. A lot of applications that we've received because it has been very affordable for customers who need to replace their rooftop units. And it has the benefits of reducing your gas consumption, therefore reducing your emissions, allowing our customers to meet the new code requirements. And you don't need to upgrade your electrical capacity, which is a great advantage for us. Now, switching back to residential. We run a pilot in 2024. We call it the early adopter pilot for dual fuel heating systems in residential customers. This is an ERS4 system that they usually used to have a furnace to heat their homes. And this new system has the gas fire component is a furnace, and then we have the electrical component, which is an air source heat pump. This has a benefit because in BC, typically we didn't need mechanical cooling in our homes because the climate was very mild. But during the last year, we've had several events for heat domes, and now the need for mechanical cooling has increased, and this is one of the motivations that for our customers to get a dual fuel system, because they will have the additional benefit that they will have mechanical cooling in their homes. Of course, this has to be controlled by a thermostat, a control system that is able to work efficiently with both. As you know, the heat pump and the furnace should not work at the same time, otherwise you're going to run into problem. And also the switchover temperature has to be as established in our guidelines. The switchover temperature that we established was 5 degrees C or lower for the lower mainland and Vancouver Island, and 2 degrees of lower for the southern interior and the northern BC regions. These are the split of the participants on the pilot. As you can see, well, all the major manufacturers participated. This is not a new technology. It's been around for a while. We just haven't tested it before. And I believe the number of manufacturers that are approved now it has increased over the time. We are company agnostic. As long as you can meet the minimum efficiency requirements, you will be able to participate or be part of this rebate. We just wrap up this pilot. Unfortunately, I cannot share results with you today because we just finished it and we're working on the results. But I can share with you that it is very promising. It had very good results, and in many cases, most of the cases, we meet the minimum efficiency that we were looking for. Now switching back to this is a product. This is a different configuration that I wanted to share with you. This product is Napoleon EQ Fusion. Is not commercially available at this moment, but I wanted to show you all the other technologies that we are working with right now. This is a little bit different than the furnace and the electric heat pump that we're looking at. This one, instead of using a furnace, it has an air handler unit. So for the retrofits that we did, we had to replace the existing furnace with an air handler, and the electrical component that will provide your heating and cooling will be your air source heat pump. And the additional heating will be provided by a tankless gas boiler. This tankless gas boiler serves heating coil in the air handling unit and is controlled by a three-way valve. So your gas boiler will top up whatever energy or heating cannot provide the heat pump. Again, this is a great help because we don't have to resize or size our heat pump for the coldest day of the year. We typically size for cooling, and then we get whatever heat we can from the heat pump. But so far, it has been adequate for the heating needs for our customers. Other advantages that this tankless gas boiler will provide domestic hot water, and it can work in conduction as opposed to the furnace and the heat pump that can be one or the other. This can be working simultaneously. So the heat pump will provide the heat at mild outdoor conditions, and when it's not able to keep up with the heat, then it will start receiving additional heat from the boiler, and eventually at very cold outdoor temperatures, the heat pump will stop and the boiler will take over. We installed this system at 20 homes earlier this year, and it's been tested. It's going pretty well. We've had a great acceptance in our customers, and we're expecting to have success on this technology too. Now, this is another system that I wanted to share with you today. We don't have an incentive for this type of systems yet, but is on the work. It's probably going to happen by the end of this year or sometime next year. We're working on the business case for the pilot program. This is a heat pump hybrid solution, a dual fuel solution for hydronic applications. In this system, we have, again, our electrical component is our air source heat pump. In this case, it's an air-to-water heat pump that supplies a hydronic loop. And this is usually used in radiant floor heating applications. And again, the additional heating, if required, has to come with this tankless boiler that can also provide domestic hot water to your home. This system cannot provide also cooling as it is. You will have to install some fan coils to provide cooling. But it's a great application as we have a lot of radiant floor heating homes in the province. Now switching back to commercial, this is another pilot we are working on. This is a dual fuel system for multi-unit residential building, and this consists in air-to-water heat pump and a condensing boiler, working with integrated controls. We're still working on different configurations, different brand. The one that I'm showing here is from ABC, but we will work with whatever product we find suitable for our pilot. The recruitment will begin, probably it's not going to be June, probably it's going to be later than that, but it is going to start in this year, and we're hoping to get some installations before this heating season. And the concept is very similar. The air source heat pump will provide hot water for your hydronic loop, and then at a certain temperature, it will switch over from the heat pump into the gas boiler. This is another product we're looking into for our pilot. This is from Galetti. This can provide temperature, a very heating at a very low temperatures. We're looking into how it can work in our pilot. Now I want to share with you another configuration we're working on. This is for a dual fuel electric heat pump with a gas heat pump. And this is going to have the benefits of both technologies because the gas heat pump has some benefits and the electric heat pump has other benefits, as we're going to see later on. But it's still in development. So there's a couple of companies, SMTI and Homey Building Solutions, that are working on the development of this product. Expected timeline will be 2027, 2028, and for sure we'll run a pilot shortly after that. Now, in terms of pros and cons for a dual fuel heating system, let's start with the pros. Well, the main one is to reduce the gas consumption. That will result in reducing emissions for our customers and reducing the risk of electrical service upgrades. We saw in our commercial, in our residential dual fuel pilot, about 90% of our customers didn't have to upgrade their electrical capacity at all. You will have an increasing comfort as the heat pump at a lower temperature will have to will operate at a lower capacity, and then you will run into a defrost cycle. But with a dual fuel heating system, you don't need to do that because at low outdoor temperatures, your furnace will be providing your heating. Also increasing resilience. First of all, you have redundancy. If one piece of equipment breaks, then the other one can take over, and it will give you a little bit of time for you to make all the repairs, and then you will not have no heat in your building. And another aspect that we're considering, and we're seeing this in our electrical service territory in Kelowna, as we are electrifying more and more on HVAC systems, but also EVs and you name it, our electrical capacity has been getting closer and closer to capacity, to the maximum capacity. So we have the risk that during events such as a cold snap, our electrical grid is going to get near capacity. So we want to reduce the risk of stressing our electrical grid during a cold snap situation. Now the cons, because not everything is good news. It's expensive to install. Now you have to install 2 pieces of equipment instead of 1. So it will be more expensive. And also have higher maintenance costs because now you're servicing 2 pieces of equipment. No, not only that, not only 1. And also the cons. One thing we discovered in our pilot is that we established a switchover temperature, and the contractor who is installing the equipment is making sure that the switchover temperature is as per our specifications. And then after he leaves, the user can change those settings, or they can even override it for a valid reason, and with the thinking that it's going to be temporarily, but then they leave it on, and then all the savings that we were expecting to have are not happening. So depending on the cost of the utilities in BC, the cost of electricity is around twice the cost of gas. If you're running into situations where your heat pump is running at a low efficiency due to outdoor temperature, you can have an increase in your utility cost. Now, let's move on to gas heat pumps. First of all, what is a gas heat pump? Gas heat pumps utilize the combustion of natural gas to drive the heat pump of the system, and also can capture additional heat of the combustion to produce and to improve the overall efficiency, and we're going to see an example of that. There are 2 kinds of heat pumps that I want to talk to you today. One is the gas engine heat pumps, and the other one is the gas absorption heat pumps. Let's start with the gas engine heat pumps. The concept is very simple. The gas engine heat pumps utilize the same vapor compression cycle as an electric heat pump. The only difference is that the gas engine heat pump has an internal combustion engine powered by natural gas to run your compressor. And this is the only difference. And another advantage, and this is a product from Yanmar that I'm showing here on these graphics, is that in cooling mode, the unit has an option to provide optional hot water from the exhaust gas heat that is being recovered into producing hot water for the building. Although this function is not available in heating mode. This is a couple of products again from Yanmar. We run a pilot that we're going to close off pretty soon. We have outstanding results with this equipment. Our customers really like it, and the efficiency that we were expecting was achieved. However, these two units use refrigerant R410A, and their future is uncertain in the North American market. So we are probably not going to move ahead with an incentive for this product. We're going to see if there is any other manufacturer or a model from Yanmar that comes out, and then we'll revisit the possibility for a rebate for this product. Now let's talk about gas absorption heat pump. Now, for those of you not familiar with the gas absorption cycle, I'm going to give you a 10,000 feet high view of what it is. We have here a little schematic. As you will see here, you will recognize some components that are the same as the vapor compression cycle. On the vapor compression cycle, you will have a condenser, your expansion valve, and your evaporator. The difference starts when the refrigerant leaves the evaporator, and the refrigerant of choice for absorption heat pumps is ammonia. When the ammonia leaves the evaporator, it's mixing the absorber with a liquid. This liquid could be water, could be a brine, could be a proprietary liquid that is absorbed into the ammonia, and the liquid form a solution, a gas liquid solution. Then this solution goes through a pump that raises the pressure of the solution, and then it goes into a gas burner. So these gas burners do two things. One is raises the temperature, and by raising the temperature of the solution, the ammonia will boil out of the mix, and then will go through the condenser for your heat rejection. The remaining liquid will go back to the absorber to continue the cycle. In other words, think of it as your absorber, your pump, and your gas generator doing the same function as your compressor. This is the main difference, that uses a little pump and a gas burner to do the same work as the electrically driven compressor will have. And this is a very, very high level overview of how a gas absorption heat pump works. Now, regarding the products available in the market, in the left, you will have here the Rover, who's been in the market for a long time, many years, decades, I believe. And we've run an incentive program for a few years now with them, and it's been a success for our customers. In the center is the Anesi gas heat pump. This product is commercially available right now, but we still don't have a rebate for it. We're running a pilot, and we're expecting to have it completed either by the end of this year or in 2026, and then we'll go from there for a rebate program. On your left, we have the Vicot heat pump. This product is not certified yet, as far as I know, and we don't have a rep here in BC, but I just wanted to show you another player. Now, before we move any further, because most people who are not familiar with the absorption cycle, the first question they will ask is, well, how's the COP of an absorption heat pump? How does that compare with a traditional electric heat pump running on the vapor compression cycle? So here is a comparison. The two bluish lines at the top are an electric heat pump, and the two reddish lines at the bottom at a gas absorption heat pump. And I couldn't find an apples and apples comparison, but I wanted to point out two things to you, and this will be good enough for that matter. Number one is that you see here the electric heat pumps will decrease the COP and also the capacity sharply with outdoor air temperature. So here you have in the X, we have outdoor air temperature. So this will be decreasing with the outdoor air temperature for electric heat pumps. Whereas for the gas absorption heat pump, you almost have a flat line. Your gas absorption heat pump does not get much affected by outdoor temperature. And the second thing I wanted to point out to you is that they're not in the same ballpark. Your electric heat pump will be 2 to even 3 times more efficient than gas absorption heat pump. That doesn't make it worse than an electric heat pump, but doesn't make it better. You just has different applications, as we'll see. Now, why consider gas absorption heat pumps? Well, it's been around for a while. It's fully commercialized, and they have representatives throughout the country. As explained to you before, it has a cold climate performance, very cold climate performance than electric heat pump. It's not as much affected by outdoor as an electric heat pump. It can provide the 65% design capacity at minus 29 degrees C. And it could be up to 100% efficiency at minus 20 degrees C. So if you have any concerns about low outdoor temperature applications, then that would be a good option. Now, in many cases, we've seen our customers installing gas heat pumps just because they have electrical capacity constraints. And in those cases, your gas heat pump will be an excellent application. And in the case of BC, we have rebates, and it's approving our policies for energy efficiency equipment. And it could be used in any end use that requires hot water. It could be used in heating and domestic hot water if you need laundry heating, you name it. In any of those applications will be a great product for you to consider. Also, as it uses ammonia, it has zero global warming potential. If this is a concern for you, then that will be a good option for you to consider. Now, what are the target applications? Well, it's mainly best suited for any hydronic heating system, and especially well suited if you have terminal devices that can operate between 40 to 60 degrees C. But it can also be used in configurations where you don't have low temperature terminal devices. And we've done a few retrofits where we didn't have to change the terminal devices of hydronic buildings served by a boiler. But what we did is that we installed the gas heat pump in combination with the boiler, and the gas heat pump will operate under low or mild conditions, and then the boiler will take over when the heating demand increases. And these are some of the applications. They're not all, but it has been successfully installed in all these type of business, all these archetypes: hotels, restaurants, swimming pools, MRFs, long-term care centers. Now, regarding the limitations, First of all, it is expensive. In the case of FortisBC, we have a pretty generous rebate for this technology, but in many cases, it would not. It would be very expensive to install. And it's also it's been around in the market for a while, but it's not been widely installed in the past. So there's a limited number of contractors who has experience installing this equipment. And it cannot provide temperatures higher than 60 degrees C. Although Robur is working in a model that will provide higher than 60 degrees C, but it's still not in the market yet. And in many cases, you will need a boiler for backup. And it has a larger footprint for the outdoor unit, as you can see here. And you need the space for the flue gases and everything. So if there's a space limitations, then it could be a concern. Now, I'm going to show you a couple of case studies for gas heat pumps that we installed in the past. This is a long-term care center in a building in the Lower Mainland that had a large air handling unit, 100% outdoor air unit that serves, it's a multi-zone air handling unit that serves part of the building. There's two air handling units. One serves the north and the other one serves the south wind, if I remember correctly. So what we did is we installed these two gas heat pumps, and then we resized the heating coil of the hot deck to be able to accommodate the 60 degrees C from the Robur. It can also provide the main reason our customer wanted to install this unit is that this building is currently has mechanical cooling that it had been working fine for the last couple of decades, but since we started with the heat dome events in the last couple of years, they just didn't have enough cooling capacity, and they couldn't increase the electrical capacity at all. So what is going to happen is that during a normal year, the existing mechanical cooling will be running. And then if we have very high temperatures during this, hopefully that doesn't happen often, but there is a possibility, then this gas heat pump can provide also cooling, additional cooling to the unit. So these are the economics. These are a few years old, but the total capital cost was $262,000. We provided a rebate for 75% of the cost of the project, and the customer had to pay the remaining 25%. And regarding the results, it's around 35% savings compared with the pre-retrofit atmospheric boilers that was installed in the building. 66.5 tons of CO2 reduction. And these are the economic results. And now this pilot was run while the carbon tax was applicable. It's not anymore, makes it a little bit complicated. I won't go over all the details, but as you can see, the payback increase if we don't consider the carbon tax. The second case study is a multi-unit residential building in Vancouver. This had all decrepit atmospheric boilers, we estimated 80%. We didn't measure the efficiency of these boilers, but chances are we're lower than 75%. We installed 3 rubber units to serve the space heating, and then we also installed a condensing boiler downstream the heating loop. So then what happens here is that at mild temperatures, the gas heat pumps provide heating to the space up until a certain temperature, around 7 or 8 degrees, if I remember correctly. Then you will need additional heating from the boiler. And then below freezing, when the rubbers cannot provide hot enough water for the building, then the absorption heat pumps stop working, and then the boiler take over the totality of the space heating of the building. Again, around $250,000, and this is a little bit old, but just to give you an example, we provide 75% of the project value. The customer put the remaining 25%, and 30% savings compared with the pre-rate of it condition, around 70 tons of CO2 reduced. And again, the economics a little bit messed up because of the carbon tax, but these are the results: 2.1 to 2.5 simple payback with and without the carbon tax. And that's it, folks. This is the presentation. If you have any question, I'll be happy to answer.
Thank you so much, Juan. Do you have a contact slide or any means that people can get a hold of you if they have questions?
Yes, it's at the end.
Yeah. Oh, perfect. Yeah, if you don't mind leaving that up. We do have one question, and if you'd like to ask a question, you can leave it in the chat bar or the Q&A box there. Is there a way to calculate outdoor air temperature versus utility cost rate to determine the most efficient switch over to temperature by region?
The answer is yes.
Mm-hmm.
This can be done by simulations. We did a study with a consultant, and they went through the simulation. And unfortunately, this is all theoretical. But yes, it can be done. We did a study to see what is the most cost efficient for our customers. And some of these results were incorporated in our guidelines because we needed to balance the minimum efficiency that we wanted to achieve, and we didn't want to have our customers penalized with a higher utility cost. And that will depend by province, because our cost structures are different on each province.
Thank you. No other questions for now, but if one comes in the next couple minutes, I'll ask you. Otherwise, this video is going up on HRAI's YouTube page roughly a few hours after the presentation, so that's where you can find it next. And I want to thank you so much, Juan, and FortisBC for putting this on for us.
Thank you very much.
Thank you.
Thank you for having me.
All right. If there's no other questions, I wish everyone a good afternoon, and I'm sure we'll see FortisBC back soon.
Thank you.
Take care. Cheers.